Welcome to Articulate Philosophy, Critical Thinking for the IB. Before we begin, I would like to acknowledge and pay my respects to the traditional owners of Australia and recognize their continuing connection to land, water, and culture. I'm currently on the land of the Gadigal people of the Eora Nation and pay my respects to their elders, past, present, and emerging. I further acknowledge the traditional owners on the country in which you're on and pay my respects to their elders, past, present, and future. As we share our knowledge, teaching, learning, and research practices within the university, may we also pay our respect to the knowledge embedded forever within the Aboriginal custodianship of country. This is a quick outline of what we will cover in the webinar tonight. I will quickly run through some of the housekeeping, and then, of course, we'll hear from a wonderful academic, Associate Professor Luke Russell. And then, if you have any questions, feel free to email us at parts.partnerships@sydneyedu.au. So tonight's webinar is delivered in partnership with the discipline of philosophy here at the university, and it could have been possible without our wonderful Associate Professor Luke Russell and his willingness to share his expertise and insight on critical thinking and causal reasoning. We hope that everyone here for tonight finds it helpful with your upcoming assessments. Luke, over to you.
Welcome, everyone. I hope you can see my screen. So as Joyce said, I'm from philosophy at the University of Sydney, and I'm going to try and show you some of the ways that philosophers use critical thinking tools to improve our reasoning skills. And we're going to focus on causal reasoning as our example for tonight. So what is critical thinking? Well, critical thinking is one branch of philosophy. It's one of the areas that you might study if you study philosophy, but critical thinking is used in many other disciplines outside of philosophy as well. When we're studying critical thinking, we're learning how arguments work. We're trying to figure out what would count as good evidence for what. And ultimately, we're trying to improve our reasoning skills and figure out what we ought to believe. So you'll hear philosophers talking a lot about arguments, and in the study of critical thinking, we're focused on arguments, but this can be a little bit confusing. So by argument here, we don't mean two people yelling at each other. Arguments are not always aggressive or combative. The kind of arguments that philosophers are interested in are arguments in which premises are set out, which are supposed to give us a reason to believe a conclusion. So when we're focused on arguments, we are in fact looking at evidence to support a particular conclusion. Arguments are the tools that we use to help us to figure out which claims are most likely to be true, and hence to figure out what we ought to believe. So the study of critical thinking is focused on arguments, and arguments come in a lot of different types. When you study critical thinking in detail, you work through all of these different kinds of arguments. So you would look at deductive arguments, inductive arguments, abductive arguments, causal arguments, arguments by analogy, statistical arguments, and you learn how to recognize a lot of common bad moves in arguments, what we call fallacies. So that's a very broad amount of content. And in a short session, as we have this evening, where instead of trying to give an overview of all of that material, we're going to focus just on one kind of argument. So we'll be thinking about causal arguments, we'll be coming to see why they're so important, and we'll be trying to learn how to evaluate them, how to think clearly in the domain of causal reasoning. So the word causal might sound a bit weird, but the word cause is very familiar to all of us. Lots of the claims that we make are claims about what causes what. And I've got a list of examples here. Smoking causes lung cancer. Here, we're not yet at the stage of asking, are these claims true or not? These are just examples of causal claims. Smoking causes lung cancer. Vaccination causes lower rates of disease. Vaccination causes autism. Humans' carbon dioxide emissions cause global warming. Studying hard causes you to do better in exams. Higher government spending will lead to increased inflation. And living under capitalism causes people to be less happy. So this list of causal claims shows you some of the domains in which causation is discussed and debated and is important. So some of these you'll notice are health-related claims. claims about health and well-being and medical treatment very frequently are causal claims. Smoking causes lung cancer. Lung cancer is something that we all want to avoid, so therefore we shouldn't smoke. Some of these claims are more political claims. They're claims in the broader domain of politics, where the suggestion is we might need to take action as a group in order to secure or to avoid a particular kind of outcome. So that's certainly the case in relation to claims about humans' carbon dioxide emissions causing global warming. But some of these claims are just claims that are important for you as you're living your life. All of you are studying. Some of you I know in year 12, some maybe in year 11, and I believe we've even got students here in this webinar now who are in year 9. All of you are studying because you believe that studying hard causes you to do better in exams. Okay, so these causal claims crop up in lots of different areas in our lives, and you can see why we would want to be able to figure out which causal claims are true and which are false, which ones get at reality, which ones can we rely on as we're trying to predict what will happen next and often control what will happen next. So just some warnings before we get into the analysis of causal arguments, some warnings about what A causes B means. People are often very sloppy in their reasoning about causation, and sometimes it's because they get confused about what A causes B really means. You could perhaps interpret A causes B to mean every time A happens, B is guaranteed to happen. Is that what someone's saying when they say A causes B? Now, here's another possible interpretation of that claim. You might think when someone says A causes B, they mean A is the only thing that can make B happen. But I want to point out to you that both of those are misreadings or misinterpretations of the claim that A causes B. And we all know this when we think about an easy, familiar example, such as smoking causes lung cancer. Now, that claim is true. We know it's true based on lots of medical science and experimentation, right? But when you say smoking causes lung cancer, you're not saying if you smoke, you're guaranteed to get lung cancer. So this is important because you cannot show that a causal claim of the form A causes B is false just by pointing out one example in which A happened and B didn't happen, right? We all know the fact that, someone's grandma smoked all her life and never got lung cancer does not show that smoking does not cause lung cancer, okay? Here's another fact that we know when we think about smoking and lung cancer. It's true that smoking causes lung cancer, but it's not the only thing that can cause lung cancer. So unfortunately, working in a mine underground where there's lots of rock dust also causes lung cancer, right? So when you're saying A causes B, you are not implying that A is the only thing that can cause B. So let's keep those in mind when we are trying to assess causal claims. What does A cause B really mean? It means something like A happening contributes to B happening and makes it look more likely that B will happen. So when someone says smoking causes lung cancer, they mean something like this. Smoking contributes to the production of lung cancer, and if you smoke, it makes it more likely that you're going to get lung cancer. Okay, so with those warnings in place, let's move to our general question for this evening. When should you believe a causal claim? It's very tempting in this domain to defer to authorities, and sometimes that's what we ought to do. So a very brief answer to this question, when should I believe a causal claim, would be when a good authority, someone with genuine expertise, tells me that that claim is true. This is what philosophers call an appeal to authority. And sometimes appealing to authority is the best way we can figure out what we ought to believe. But there are deeper questions here, and they're really important questions. We can get at those deeper questions by asking, how do the experts themselves figure out whether a causal claim is true? How do the experts figure out what causes what? And this is important because there are also plenty of situations in which we encounter experts disagreeing with each other about whether A causes B. Right? Just think about debates about vaccinations and whether vaccinations cause good health outcomes or bad health outcomes. So we need to dig deeper than just say, let's wait for the experts to tell us whether this causal claim is true. We're going to try and dig deeper in this session. Now, I set all of you as a kind of preparatory task this question. Do you think it's true that smacking, or what Americans call spanking children, causes them to develop higher levels of anxiety later in life? And what I'd like you to do now is to go to the Q&A section and type in your answer. So don't be afraid. You can just type your answer into that Q&A box, and we've got a few answers coming in now. So Uru says it depends on the personality of the children. Classic kind of, well, maybe not. We've got another answer suggesting no, it wouldn't cause any higher levels of anxiety later in life. And another person saying, well, yeah, it might contribute to PTSD, post-traumatic stress disorder, because being smacked could be a traumatic experience. Attendees suggest that there are other things that might contribute to adult anxiety, but do you think it's true that smacking children contributes to adult levels of anxiety? Okay, now this is a difficult question. What I'd love to hear from is, are there people who you can just answer yes or no in the Q&A? You don't have to write anything more detailed than that. Are there people who think, yes, that probably does cause higher levels of anxiety later in life? So one person says yes, and here's why: because it affects their relationships with their parents, and they are foundational relationships. Okay, does anyone else agree with that kind of thing? We've got a few people saying yes. Okay, so we've got some answers there. I'm sure we've got some more detailed thoughts that we can come back to later in this session. We're going to return to this question later on. So I'm going to move from the Q&A back to the normal slides now. And we're going to ask how people answered that question. So the straightforward question is, do you think that's true? And the more challenging question is, what evidence could support that claim? What led you to believe that that's true? And how did you think it through? How did you reason about it? So here I'm going to reveal what I think people very frequently do in this domain when they're asked a causal question like this. When they encounter a causal claim of the form A causes B, most people try and imagine a mechanism via which A could cause B. In other words, they try and tell a story about how A causes B. And we saw a couple of examples of that in your responses to the question about smacking children. A couple of people thought, yep, I think that would cause adult anxiety because it would damage the relationship with the parents, or because it's traumatic and hence it would produce post-traumatic stress disorder, at least in some cases. So if you can imagine a mechanism via which A would cause B, if you can tell a story which sounds plausible where A causes B, for many people, that's enough to convince them, yep, A does cause B. Right? If the story sounds good, and often if the story makes them feel good, or if it fits with their pre-existing attitudes and beliefs, they think that causal claim is probably true. And when people ask causal questions like this, very frequently they'll include anecdotes in their story. So individual examples that they are familiar with, perhaps from their own lives. Okay, so in relation to our causal question, someone might say, smacking our children does not cause anxiety later in life because I was smacked and I don't have anxiety problems. That would be an example of an anecdote. Someone might argue in the opposite direction and say, smacking children does cause anxiety problems later in life. I've got a friend who's got severe anxiety problems who was, physically abused, physically smacked and punished by her parents. Okay, that's the standard way that people tend to try and answer causal questions. This is how we tend to think them through. Here's what I want to warn you about in this domain. It's really easy to come up with stories like this. It's really easy to invent narratives or to imagine causal mechanisms. And you can see this by just seeing how easy it is to imagine conflicting stories in this domain. Right? You can tell a story which says smacking causes anxiety problems later, and here's why. But it's very easy to tell a story where smacking produces resilience and obedience in children, and it has no bad impact on anxiety levels later in life. Anyone can come up with stories for and against like this. So we have to dig deeper than this. We have to figure out which stories are true, which stories get at the real causal connections in the world. And the big warning is lots of appealing and sometimes comforting causal stories are false. They don't match reality. So the explanation based story of why vaccines cause autism is very appealing to some people. Right? They think, yep, I can imagine how putting this dangerous thing in your body might lead to all sorts of terrible health effects later on. But for most of the vaccines that we use, there are not significant negative health effects, even though the story about how vaccines are causing these bad effects is an attractive story to many people. So how are we going to go deeper than just telling stories about what causes what? How are we going to find actual evidence? This is our task for tonight. I'm going to show you how philosophers and scientists try and build a causal argument, an argument for the conclusion that A causes B, and how they evaluate evidence for and against. The starting point typically, when we're trying to figure out whether A causes B, is an observed correlation between A and B. And we're in this session, we're going to mean something very loose by that. We're just going to take correlation to mean A tends to go with B, or A happens and then B happens. And so this is the usual starting point in a causal argument. These claims about correlations can be backed up by observations. Right? You go and watch A happening and you see whether B tends to happen after it. For example, you can go and watch people who are smoking and then track those people and then see whether they get lung cancer later on. Right? So that's one kind of evidence you'd need to look for to test the causal claim smoking causes lung cancer. You see whether smokers are more likely to get lung cancer. And notice in that case, that is a really long-term, complicated observational task. This is not something that you can do quickly or easily. Okay, here's another causal claim. Earthquakes cause tsunamis. How could we figure out that's true? The first starting point is to look for correlations between them. So let's figure out when and where do earthquakes happen? When and where do tsunamis happen? And is there a kind of matching up in the pattern of those two events? Here's a third claim. This one is kind of more part of your everyday life. Does going to an expensive school cause you to get better final results in your end of school exams? Well, the starting point in an argument for that conclusion would be to see if there is a correlation, to see whether the people who go to more expensive schools match up with the people who get higher results in the final exams. So this is step one in a causal argument. It requires observation of events of type A and events of type B, and a kind of search for a pattern or an overlap in the pattern of those events. There are some really interesting historical examples which show you that careful gathering of the observational evidence can lead to hugely important and beneficial causal discoveries. So the person you can see on your screen right now is Jon Snow. For Game of Thrones fans, you can see that that is not the Jon Snow from Game of Thrones. This is a middle of the 19th century English health researcher who was trying to figure out what caused a cholera outbreak, a deadly disease outbreak in London in the 1850s. And Jon Snow was working at a time where there are all sorts of competing theories about what caused a disease outbreak like that, including it was bad smelling air that transmitted the disease, including that it was rats that were transmitting the disease. And Jon Snow figured out what was really going on by making really careful observations. He drew up a map, and this is a very famous map that you can now see on your screen in medicine, and more specifically in the field of epidemiology. So Jon Snow put together a record on this map of where the particular victims of this cholera outbreak died. Where were they living? Where did they die? And you can see the black dots, hopefully, on that map. And Snow used those observations to come up with his theory for what actually caused this cholera outbreak. Now, one of the things he needed to explain was, why are those dots all clustered around the street you can see in the middle there that's called Broad Street? So Snow came up with the theory based on these observations that in fact this cholera outbreak was being spread by contaminated water that people were drawing from the well that was on Broad Street. It was not an airborne disease or a disease that was being spread by rats. It was being spread by contaminated drinking water. Okay, so that is step one in a causal argument. You need to go out and make your observations, and sometimes that might be a very difficult task. It might require systematic work, sometimes years of observations. But in many cases, we can make the required observations much more easily. Now, you may have heard of this phrase. This is a very famous phrase about causation. Correlation does not imply causation. If you come to university and you study one of the social sciences, or you study psychology, sociology, right, you will hear a lot about this. Correlation does not imply causation. What does that mean? Remember, correlation just means these two events tend to go together in a regular pattern. What's being suggested in this phrase is that sometimes A does go with B, even though A doesn't cause B. So sometimes there is a pattern that you've noticed, A happening and then B happening, even though A does not cause B. And there's a kind of little cartoon joke here to illustrate this claim. I used to think that correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe it did. So this is classic nerd humor. Why? Well, maybe this person has learnt in the statistics class that sometimes something that happens after a particular event was not caused by that event. Correlation does not imply causation. Now, this claim is true, but we've got to be careful. There are people who, whenever you make a causal claim and try and provide evidence in support of it, will say, oh, but correlation doesn't imply causation. I'm just going to reject your claim. So an example of this might be if you say, here is the observed correlation between carbon dioxide levels in the Earth's atmosphere and increased temperatures around the globe, your critic might say, oh, but correlation doesn't imply causation. I see those trends are matching up, but that doesn't show that the first thing is causing the second thing. What we need to do in order to reason clearly and carefully about causal claims is to move beyond the fact that correlation does not imply causation and learn how to build more powerful and more rationally persuasive causal arguments. So how are we going to do this? Here's, sorry, just one more slide to illustrate the fact that correlation does not imply causation. If you look at trends, if you look at patterns in the frequency of different kinds of events, sometimes you find some weird overlapping trends where it looks like, oh, one of these events is declining or increasing in sync with the other event. So this is a funny graph. This is from the website Spurious Correlations, showing that for these years, the divorce rate in the United States state of Maine was very closely correlated with the amount of margarine that was eaten per person in that state. Right, so when you look at those two patterns matching up, you might think, oh, this is a case maybe where getting divorced causes people to eat more margarine, or eating less margarine causes the divorce rate to go down. These would be very strange claims. So what we're supposed to take from this graph is, in fact, a different lesson. It's that sometimes events match up with each other and trends match up with each other, even though there's no causal connection between them. Okay, so how are we going to go further than just admitting that correlation does not imply causation? How are we going to get to a point where we've built a stronger causal argument? And what extra evidence do we need to look for to figure out whether A really does cause B? Now we're at the point where we're going to set out what philosophers say about good causal arguments. So this is a very brief structure of a good causal argument. The first premise is A is correlated with B. We've observed that when A happens, B tends to happen, or something like that. And then the second premise of the argument is the best explanation of A being correlated with B is that A causes B. And the conclusion will be, therefore, A causes B. So this argument in the context of, say, smoking and lung cancer would be, smoking is correlated with getting lung cancer, and the best explanation of that observed correlation is that smoking causes lung cancer. Therefore, smoking causes lung cancer. Now, you might have noticed that there's something weird going on in the second premise of that argument. The claim, the best explanation of A being correlated with B is that A causes B. Here's what you need to ask. The best explanation compared to which other possible explanations of the observed correlation? All right, I'll say that again. The key to understanding causal arguments is to notice that there are multiple possible explanations of why A might have been followed by B. So we need to ask, what is the best explanation of A being correlated with B? Is it A causes B, or is it one of the alternative possible explanations of why those things go together? Now I'm going to talk you through 3 alternative possible explanations of why A might have been observed to go with B. So we've seen already, one of those possible explanations is that A might have caused B to happen. It might have made B happen. But what are 3 alternative explanations for why A might go with B, even though A does not cause B? Here's the first one, and this is really easy to understand. Maybe A happened and then B happened, but they went together merely by coincidence or merely by chance. There are lots of events like this. You might have experienced this in your own life. Sometimes, for example, you might press a button and somewhere in your immediate vicinity, there's a loud noise and you automatically think, hang on, did I cause that by pressing the button? You kind of recoil and think, oh, did I do that? So when one event happens and another happens immediately after it, our brains are wired to automatically wonder whether that first event caused the second event to happen. But in lots of cases like that, the two events went together merely by chance. Here's an example to illustrate this. A very frequent belief back before we had sophisticated scientific investigation, before we had detailed knowledge of what's going on in the night sky, before we had a better understanding of medicine, a common explanation of plagues was a comet appeared in the sky and that caused the plague. The comet was something that kind of transmitted that disease to Earth. We might look at that now and say, okay, that's a pretty implausible causal claim. But if you imagine yourself back into that time, it's pretty easy to see how someone might jump to that conclusion. They might say, we observed a comet, and then quite soon after that, there was a plague. So the comet must have caused the plague. Now, if you are a careful causal reasoner, you need to slow down and think, well, maybe the comet caused the plague here, but maybe those two events went together merely by chance. So here's the big question. How would you rule out the idea that these two events occurred together just by chance? And the answer's pretty obvious, even though it's impossible to implement or very difficult to implement in the case of comets. The test that we use to figure out whether A went with B merely by chance is to make A happen again and watch to see whether B happens. Right? So we make repeated observations or we carry out repeated tests. And if again and again, when A happens, it's followed by B, or if when A happens, it's usually followed by B, that is going to lead us to say this was not a coincidence. There is a regular pattern here. Right? So repeated observations or trials are the method that we use to rule out A having gone with B merely by chance. But of course, sometimes we discover when we observe other cases of A that it's not regularly followed by B, and we do draw the conclusion that A went with B just by chance. A didn't cause B, it was a mere coincidence. Okay, so that's the first alternative explanation of why A might have happened with B. That's pretty easy to understand. Here's the second one, and this is also really easy to understand, but a lot of people miss it in their thinking. A lot of people just ignore this possibility. Maybe A is correlated with B and is even regularly correlated with B, but it's not because A causes B. Maybe that's because B causes A. Right? Maybe there is a causal connection, but it doesn't go from A to B, it goes from B to A. So what test could we use to figure out whether it's A causing B or B causing A? Well, let's think about the observed correlation between earthquakes and tsunamis. We might ask, if these events regularly go together, is it more likely that the earthquakes are causing the tsunamis or that the tsunamis are causing the earthquakes? Could it be B causing A? And there's a very simple test that's available to us in many cases here. You might have figured this out. What we do is we try and measure which event happened first. We try and figure out the temporal order or the order in time of those two events. So do earthquakes cause tsunamis or do tsunamis cause earthquakes? Well, we can rule out the second of those because when we look at our observations, we see a regular pattern in which earthquakes happen first, and then tsunamis, when they do happen later. They happen after the earthquake. So given that causation works forward in time and not backwards in time, we know that if A happened before B, then B did not cause A. So that's our test to try and rule out the second alternative possible explanation of why A might have gone together with B. Now, here is the third one, and this is where things get a bit more difficult. But this is hugely important. Sometimes A is correlated with B. A tends to go with B. But it's not because A causes B, and it's not because B causes A. Instead, it's because there's a third thing, C, which causes A and independently causes B. Right, I'll give you some examples in a second, but first just look at these diagrams. So what we're talking about here is the first diagram where we've got C and then a branching structure to A and B. Right. C causes A and C also causes B. A doesn't cause B, B doesn't cause C. If that is what happens in the world, then when C happens, we can expect A and B will probably happen, and there will be an observable correlation between A and B. So just to be clear, we're not talking about something like that bottom diagram on the screen where C causes A and then A causes B. We're talking about a branching causal structure. Now, here are some examples to help you understand this idea. Remember, this is a possible explanation of why A might be correlated with B, even though A does not cause B. Night is correlated with day. When there's a night, you know there'll be a day not too long after it. When there's a day, you know that a night's going to follow it. You might be tempted to say, okay, maybe day causes night and then night causes day. But we know with our knowledge of how the solar system works, that in fact, day doesn't cause night, night doesn't cause day. There's a third thing, the rotation of the Earth and the light being shone at us from the sun that causes day and then causes night and then causes day. So here's another example to illustrate this branching causal structure. You might make observations about the number of drownings, a tragic event, one that we care about, one that we want to reduce. And you might notice that at certain times of the year, the number of drownings significantly increases. And then you might say, hey, this is at the same time of the year when people eat more ice cream than they do at other times in the year. There's a correlation between increased drownings and increased consumption of ice cream. But we can see pretty easily that eating ice cream is not what's causing the drownings. Instead, there's a third thing which causes an increase in ice cream consumption and independently causes an increase in the number of drownings. And hopefully you can see what that third thing is. It is summer. It's the increased heat in summer. Causes people to eat more ice cream, a lovely cool snack when it's hot, and independently causes people to swim more often and hence results in more drownings. So even though there is a correlation between increased ice cream consumption and increased drowning, it is not the case that people eating more ice cream is the cause of more drownings at that time of the year. So hopefully you understand from that example that in a situation like this, you will observe A regularly going with B, even though A does not cause B and B does not cause A. So this is where things get tricky. I'm going to skip this example and come back to it potentially later. How can you test when you've got an observed correlation between A and B, whether A is causing B or B is causing A, or whether there's a third thing, C, that's independently causing both? Right, here is the test that you can use. You try to hold C steady, and then you increase or decrease the magnitude of A. We can describe this as holding C steady and wiggling A. And then you watch to see whether B increases or decreases in sync with the changes that you're making to A. So we can call this a wiggle test. Right, what you're doing, and this is what scientists very frequently are doing, if they're trying to figure out whether a particular medicine causes a good or a bad health outcome, they'll try and hold all the other facts steady and give some people the medicine and don't give it to the other group. Right, they're wiggling A, wiggling whether you've had the medicine or not, while holding the other things steady, and then they watch to see the health outcomes. They try and see whether the disease is more likely to happen. Okay, so This is a wiggle test, and this is what philosophers and scientists frequently use when they're trying to figure out whether the observed correlation between A and B is due to a third thing, C, that causes both of them independently, or whether in fact A is causing B or B is causing A. And here's a classic example of this. This is from Australian scientists, right? So stomach ulcers are painful and dangerous. You don't want to end up with a stomach ulcer. The standard explanation for what causes stomach ulcers was, back in the day, high levels of stress cause people to have higher levels of acid in their stomach, and that produces ulcers. So the recommended treatment for stomach ulcers was you should quit your stressful job, relax, go and play some golf, and take antacid medications. But then in the 1980s, a couple of Australian scientists, Marshall and Warren, observed a correlation between having a stomach ulcer and having high levels of a particular bacterium in your stomach. That bacterium is Helicobacter pylori. And they proposed that maybe stomach ulcers are usually caused by a bacterial infection rather than by stress. And most doctors didn't believe them. So how are these scientists, how are these medical researchers going to convince the doctors that it is the bacterial infection that's causing the disease? They did a wiggle test, and a really gross one, right? So Marshall infected himself with the bacteria, and then he noticed he started to develop a stomach ulcer, right? And then he took antibiotics, which killed those bacteria, and the stomach ulcer started to get better. So he was wiggling the level of bacteria in his stomach, and he noticed that the stomach ulcer developed and then went away as he wiggled that. That's very strong evidence that the stomach ulcer is caused by the bacterial infection. So here's a tricky question. If stress is not something that causes stomach ulcers, why was there an observed correlation between being stressed and having a stomach ulcer? Stress is not the cause. Why do those things typically go together? If you think this through, you might be able to spot the answer. Here's why. In this case, having an ulcer causes you to be really stressed because having an ulcer is painful and distressing. So this was a case where A went with B, but it was not A that was causing B. There was a third thing causing both. Okay, so we're at the end of the content, and we're going to come back to this question. How are we going to evaluate a causal claim like smacking children causes them to have higher anxiety levels later in life? What evidence would we look for to figure out whether that claim is true? Now, here's what I want to steer you away from. We shouldn't be asking, what stories can I tell about whether this kind of nasty activity has bad effects or not? Right? Instead, we're going to need to work through a structured causal argument. And so the first thing we're going to need to do is measure levels of smacking and levels of anxiety later in life, right? Make those observations and see whether there really is a correlation between those things or not. And we might discover that there's no correlation there. Suppose we do discover a correlation. Suppose we think people who are smacked as children are more likely to have higher levels of anxiety later in life. Does that mean we've got great evidence that smacking causes high anxiety? Let's work through the argument. Step 2, could that correlation be due to mere chance? Well, not if we'd made lots of repeated observations. Could it be B causing A? In this case, no, because the anxiety levels later in life cannot retroactively have caused you to be smacked when you're a child. But here's a really interesting alternative explanation that we would need to think through. Could there be a third thing, C, which causes children to be more likely to be smacked and independently causes them to have higher levels of anxiety later in life? Can we do a wiggle test to figure out whether it's the smacking that causes the higher levels of anxiety or something else which causes children to be more likely to be smacked and causes them to have higher levels of anxiety later in life? So these are the kinds of evidence that philosophers and scientists would look for to try and test these claims. And this is very different to just coming up with a story that vindicates your prior assumptions. So here are some more causal claims for you to test back at school. You're going to get a PDF of all of these slides to take away and work on. So if you're a teacher in this session, these are some examples of causal claims that you might want to test with your students back at school. And what I'm recommending here is you test them not by sitting around and telling stories about them, but by trying to come up with a structured causal argument where you are working through the alternative possible explanations of an observed correlation and seeking evidence as to whether one of those alternative explanations is the correct one, or whether, in fact, it's more likely that A goes with B because A is causing B. Right? So the key lesson here is you don't know what causes what until you've worked through that kind of argument. And hopefully you can see the huge benefits to figuring out what causes what. You can do things like, for example, come up with good, effective treatments for stomach ulcers. Okay, so a summary for you. Remember, you'll have these slides. So if you're considering whether A really causes B, you need to work through all of these steps, see if you can do a wiggle test or see whether scientists have done wiggle tests. Don't just believe the first story that you're told when it comes to claims that something causes something else. You need to use critical thinking to seek more evidence. Okay, so we're going to go to the Q&A.
I just wanted to say thank you so much for this wonderful presentation, Luke. And as I said, if you have any questions, feel free to just type them into the Q&A. Look, we've got the first one from an anonymous attendee.
Okay, so the question is, how would you suggest applying what's been learnt tonight to an IB theory of knowledge exhibition? Okay, so in theory of knowledge, you are studying more generally, how do we acquire knowledge? What is knowledge? And this has definitely got a lot of philosophical content in it. How are you going to apply it? I think it's going to depend on what kind of questions you're trying to answer in theory of knowledge. So if you are thinking about, say, scientific knowledge or knowledge in relation to health and well-being, then I think it's pretty straightforward how you would use these standard kinds of causal argument and apply them to claims about, the health benefits of various kinds of medication or treatment. You might also be thinking about things outside of the domain of health where you are encountering causal claims. As we saw earlier, very often those claims crop up in the domain of politics, right? Will this particular government policy produce this desired outcome, or will it instead have disastrous effects? It's really easy to tell stories that fit with your prior beliefs, right? But if you want to figure out what will cause what, you need to try and work through those causal arguments, make observations, and see whether A really does go with B, and see whether the fact that A goes with B is best explained by A causing B or by one of those other possible explanations. If you've got more specific questions about, more specific IB content, I'm happy to discuss that as well. Okay, we've got another question here now. What are my views on smacking and spanking children in regards to the development of higher levels of anxiety later in life? Okay, I deliberately chose an example that I don't have expertise on, but one in which a lot of people have very strong emotional reactions. So smacking children is something that was, rarely or never done in my household, and I'm glad for that. But at the same time, so I think, smacking children is distressing for the child when it's happening. But I just don't know whether smacking children has bad long-term effects on their personality. And this is something where I looked at a couple of scientific papers, and you do see some scientists making what they call observational studies about this, where they are not actually doing a wiggle test. You can see why they're not. I'll explain that in a second. They're just looking for correlations between children who were smacked when they, people who were smacked when they were children and people who've got higher levels of anxiety later in life. And they say they do see those correlations. But what you'd need to do to draw a confident conclusion about what's causing what here is to really work through those alternatives. In particular, you'd want to know whether there are third things that might cause children to be more likely to be smacked and independently cause children to have higher anxiety levels later in life. So I'm not claiming to know that this is true. Instead, I'm proposing this as a hypothesis that needs to be tested. Imagine that there are some children who've got innate temperaments that are more aggressive and disobedient than other children, right? So this is something that my mum says to me. She says, some of you children, came out different to the others. You're all part of the same family, but you have different temperaments. Now, here's a possible explanation. If you're a child who's kind of more innately naughty and disobedient than other kids, that might cause you to be smacked more often because you get in trouble with your parents more frequently. And maybe it would also cause you to have anxiety problems later in life because you're getting into other kinds of frustrating clashes later in life. That's a possible explanation of that correlation. So this is one where you would really need to work through that data in a whole lot more detail and consider alternative explanations of the observed correlation. Once again, I just need to make it really clear, I don't have expertise on that question, but just setting up this discussion task made me think, oh, okay, I need to go and read a bit more of that and see whether scientists have done those kind of studies.
Thank you so much for this, Luke. Just a question following up from that is, where can students and teachers find more resources relating to these topics in regards to causal claims and arguments?
Okay, great. So I just want to really quickly say there's another fantastic question in the Q&A. In different cultures, there are different patterns of child rearing, and that's relevant data for this question. Okay, so Joyce is asking, where can students find more information? There's a good book that you can find called Critical Thinking, The Basics, written by an author called Stuart Hanscom. There are quite a few critical thinking textbooks that you can find online. And so they're places you can look. Of course, it'd be fantastic to see some of you eventually coming to the University of Sydney and studying more critical thinking in the philosophy department with us, where we've got dedicated courses where you can work on these critical thinking skills.
Perfect. Thank you so much for this, Luke. Greatly appreciated. To stay up to date with any upcoming events or similar opportunities that we might have, you can also sign up to our Faculty of Arts and Social Science Participate high school newsletter. You can also find a copy of this on our webpage for your reference as well. We also have one more articulate talk coming up for Commuter and Family Studies next week. You can view more information and register by scanning the QR code on the left. You can also have a look at previous articulate talks, podcasts, or other learning resources curated on our webpage, which is the QR code on the right. Thank you so much, everyone. Wishing you a wonderful night ahead, and we hope to see you again very, very soon.